Find the fourth roots of I in exact polar form. So z to the 4 is equal to I, and then we want the various values of z, so we're getting the fourth roots. So z to the 4 is going to be cis pi by 2 plus 2n pi, where n is an integer. Just think about where I is. It's just here on the imaginary axis, a distance of 1 from the origin. So for the principal argument, that's pi by 2, but remember we can get to that every time we go around in either direction, no matter how many times, and that's where the 2m pi comes from. So by demois, z is going to be cis pi by 8 plus 2n pi divided by 4. So that's cis pi by 8 plus n pi by 2. So now it's just a case of taking some values of n and making sure we stay within the principal argument range. So n equals 0 is an obvious one, so that's going to give us cis pi by 8. If we have n equals 1, that's going to be cis pi by 8 plus pi by 2, which is cis pi by 8 plus 4 pi by 8, so that's 5 pi by 8. Now if we went for n equals 2, we'd be adding another pi by 2 onto this one, so that would be 9 pi by 8, so that would go outside of our principal argument between negative pi and pi. So n equals negative 1 is the next one I'd try. So we've got pi by 8 take away pi by 2. So that's going to be cis negative 3 pi by 8. And if we take n is negative 2, so what we're doing is pi by 8 take away essentially pi. Or the easiest way to do that is take another 4 pi by 8 from this one, and that's negative 7 pi by 8, and all of these are in the correct range. So what we could do, if we want to label them in order smallest to largest angle, we could say Z1 is cis negative 7 pi by 8, Z2 is cis negative 3 pi by 8, Z3 is cis pi by 8, and Z4 is cis 5 pi by 8. And those are our 4 solutions.